Questions number 1. Table 1 shows 3 types of bungalows built by Syarikat Pemaju Makmur in Taman Sejahtera, Kuala Lumpur. The construction costs and the selling prices are different for each house. Syarikat Pemaju Makmur has issued a capital of 630 million to build 3 types of houses. At the end of last year, the company successfully sold 140 units of types A, B, and C houses with the total profits of Rm 515 million. Find the number of units of each type of house that was successfully sold last year. So this question is about the system of equations. So here, let's say we use the letter A, B, and C to represent the number of units of each type of households. Then we're going to form 3 equations. So the first equations I'm going to form using the informations the company successfully sold 140 units of type A, B, and C houses. Then here the equations will be A plus B plus C equal to 140. For the second equations, using the informations, the company has issued a capital of 630 million to build 3 types of house. So this is referred to the construction costs. Then the equations will be 3A plus 5B plus 6C equal to 630. And the other equation we're going to use total profits of Rm 515 million. To find the profits, we're going to use the selling price minus the construction price. So for the house types A, 5.5 minus 3. Then here the profit will be 2.5 million. And for house type B, 9 million minus 5, then the profits will be 4 million. And for the house type C, 11 minus 6, then the profits will be 5 million. So the third equations will be 2.5A plus 4B plus 5C. So this is equal to 515. To solve this, first we're going to label these equations as 1, 2, and 3. So here I'm going to solve these questions using the eliminations method. And the variable that I'm going to choose to eliminate will be the variables B. So here, for the equations number 1, I'm going to multiply it by 5. So that it will equal to the variable B's in equations number 2. So the equations now will be 5A plus 5B plus 5C. This is equal to 700. And I'm going to label this as equations number 4. So to eliminate the 5B in equations 4 and 2, I'm going to use equations 4 minus equations 2. So here we're going to get 2A minus C equal to 70. And I'm going to label this as my equations number 5. Next, for equations number 1, I'm going to multiply it by 4 so that it will equal to the variable B's in equations number 3. Now the equations will be 4A plus 4B plus 4C equal to 560. So this will be the equations number 6. So to eliminate the 4B in equations 6 and 3, I'm going to use equation 6 minus equation 3. So here we're going to get 1.5A minus C. This is equal to 45. And this will be our equations number 7. So now using equation 5 and 7, we are going to continue to eliminate the variable C. To eliminate the C in equation 5 and 7, I'm going to use equation 5 minus equation 7. So here we're going to get 0.5A equal to 25. So A is equal to 25 divided by 0.5, which is equal to 50. So next, I'm going to substitute the A equal to 50 into equations number 5 to find the value of C. So here we're going to get 2 times 50 minus C. This is equal to 70. So C is equal to 100 minus 70, which is equal to 30. So next, I'm going to substitute the A equal to 50 and C equal to 30 into equations number 1 to find the value of B. So we're going to get 50 plus B plus 30 equal to 140. Then B will equal to 140 minus 60, which is equal to 80. Questions 2a. Diagram 1 show the graph of y equal to a to the power of x. 1. On the diagram 1, sketch the graph of y equal to log base a of x. So here y equal to a to the power of x is written in index form. If we change the index form here into logarithmic, then we're going to get log base a of y is equal to x. So here, if you notice, you are changing the subject of the formula from y to x. In chapter number 1, functions, when you change the subject from y to x, what you're going to get will be the inverse functions. So here, for example, if I let f of x is equal to y, then the inverse of y will equal to x. So here we can set the inverse of y is equal to log base a of y. Then the inverse f of x will be log base a of x. So the graph of the inverse functions is the reflections of the graph of that functions in the lines y equal to x. So this will be the straight line y equal to x. So this will be the reflections look like. So here will be the 1. And for this point after the reflections, so the coordinates here will be 4.0 and the y will be 0.6. Number 2, give justifications for the sketch. So y equal to log base a of x is the inverse of the y equal to a to the power of x. Questions B1. Simplify log base 3x minus 1 minus log base 9 of x squared. So always refer to the formula 5 to 8 given when you are solving for the question's logarithm. So first, using the formula number 8, I'm going to change the base 9 here to base 3. So it will be log base 3 of x squared over log base 3 of 9. So for the number 9s here, we can write this as log base 3 of 3 squared. So here using the power law, which is the formula number 7, we can move the 2 to the front. Then it will be 2 times log base 3 of 3. So log base 3 of 3 is equal to 1. So when multiply by 2, then we're going to get over 2. Next, for this part, I can write this as 1 over 2 times log base 3 of x squared. Next, using the power law, I can move this 1 over 2 as the power of the x squared. So here when 2 multiply 1 over 2, we can cancel this, so we just left with the x. So now using the differentiation law, which is the formula number 6, we can simplify this as log base 3 of 3x minus 1 over x. Questions B2. Hence, solve the equations log base 3 3x minus 1 minus log base 9 of x squared equal to negative 1. So from questions B1, we already simplified this part. So now these equations will become log base 3 of 3x minus 1 over x equal to negative 1. To solve this, you can change this logarithmic form into index form. Or you can also change this negative 1 into log base 3. Then we can do comparisons. So first, I'm going to write this as log base 3 of 3. This is equal to 1. To get the value of negative 1, so for this log base 3 of 3, I'm going to put the power as negative 1. So when you are using the power law, you bring the negative 1s to the front. It will be negative 1 times log base 3 of 3. Then you're going to get negative 1. So now on both sides, we're having the same log base 3. So now we can compare for this part. So 3 to the power of -1, this is equal to 1 over 3. So here we're going to cross multiply this. So 9x minus 3, this is equal to x. So next we're going to get 9x minus x is equal to 3. So at x equal to 3, then x is equal to 3 over 8. Questions number 3. Diagram 2 shows a triangle PQR. The straight line PU and the straight line SR intersect at points T where TR equal to 405 SR and PU equal to 2PT. Given that PR equal to X and PS equal to Y. A expressed in terms of X and OY. Number 1, PT. So first, based on this information, here you can write this as TR over SR is equal to 4 over 5. Then from here, we know that the ratio of the TR is equal to 4 and the ratio SR is equal to 5. So the ratio ST will be equal to 1. And based on these informations, we can write this as PU over PT. This is equal to 2 over 1. So from here, we know that the ratio PU is equal to 2 and the ratio PT is equal to 1. So the ratio TU is also equal to 1. This means the point T is the midpoint for PU. So next, let us label these two vectors on the diagram. So the PR here is equal to X and the PS here is equal to Y. So to find what is the vector PT, here using the triangle law, you can use PT equal to PS plus ST or PT equal to PR plus RT. So here I'm just going to use PT equal to PS plus ST. So we already know what is the vector PS. So now we need to find what is the vector ST. To find vector ST, first we need to find what is the vector SR. So SR is equal to SP plus PR. So here we're going to get negative Y plus X. And from the ratio given, we know that ST is equal to 1 over 5 SR. So here we're going to get 1 over 5, then the SR is the negative Y plus the X. After we expand this, then we're going to get negative 1 over 5Y plus 1 over 5X. So now we can find the vector PT. So it will be equal to Y plus negative 1 over 5Y plus 1 over 5X. So here we're going to get 4 over 5Y plus 1 over 5X. Number 2, to find the vector RU. Again, using the triangle law, we can set RU is equal to RP plus PU. So RP will be equal to the negative vector X plus PU is 2 times the vector PT. And in questions A1, we already find what is the vector PT. So this will be 2 times 4 over 5 vector Y plus 1 over 5 vector X. So expand this, you're going to get 8 over 5 vector Y plus 2 over 5 vector X. So here solve the vector X, you're going to get negative 3 over 5 vector X plus 8 over 5 vector Y. Questions B. Given PQ equal to HY and RQ equal to KRU, where H and K are constants, finds the value of H and of K. So here we have been given with the vector PQ, and for the part vector RQ, we already know that what is the vector RU in questions A. So it's equal to k times negative 3 over 5x plus 8 over 5y. So expand this, we're going to get negative 3 over 5kx plus 8 over 5ky. So now let us focus where is vector PQ and RQ on the diagram. So here will be the vector PQ and here will be the vector PR. So here using the triangle law, we can connect these two vectors using the vector PR or RP. So here, let's say I connect this using the vector PR. Then PR will equal to vector PQ plus vector QR. So vector PR is X. PQ, we know that is equal to HY. And for the QR, it is moving in the opposite directions of the RQ here. Therefore, the vector QR will be positive 3 over 5kx minus 8 over 5ky. So for the part vector y here, we can factorize this. So it will be bracket h minus 8 over 5ky. So now we can compare the vector x with vector x and vector y with vector y on both sides. So when you compare vector x, you get 3 over 5k, this is equal to 1. Move the 3 over 5 to the other side, then k is equal to 5 over 3. For the vector y, on the left hand side we don't have any vector y, therefore h equal to 8 over 5k, this will be equal to 0. So here we're going to substitute the k here with the 5 over 3. So h is equal to 8 over 5 times 5 over 3. So here we can cancel the 5. So h minus 8 over 3 is equal to 0. Then h is equal to 8 over 3. Question number 4. Diagram 3 shows an electric wire between pole A and pole B, which is 7 meters apart. The height of the both poles is 10 meters. On a certain day, the electric wire has sagged and formed a parabolic shape such that the minimum height of the wire from the ground is 3 over 4 of the height of the pole. A1 finds the equations of the parabolic shape electric wire in the vertex form where P and Q are constant. Assume A as the points of origin. As points A is the origin, then we can set that a pole A is going to be the y-axis and the ground is going to be the x-axis. In vertex form, the P and Q here is referred to the x and the y coordinates of the minimum points or the maximum points. In this case, this is going to be the coordinates of the minimum points. So based on the diagram, at the center here, this will be the minimum point with the coordinates of P and Q. As P is in the middle of the pole A and B, then the coordinate x will be 7 over 2. And for the Q, which refer to the heights of the minimum point, this will be equal to 3 over 4 of the heights of the pole, which is 10. So this is equal to 15 over 2. So next, we're going to find what is the value of A. So now the equations of the vertex form will be A bracket x minus 7 over 2 square plus 15 over 2. To find the A, we need to substitute the fx and the x with the coordinates that we know on the curve. So here the y, this is equal to the fx. So one of the coordinates that we know will be the y-intercept here, which is going to be 0, 10. So here the fx, we're going to substitute it with 10 and the x with 0. So next we're going to get 10 minus 15 over 2. This is equal to a negative 7 over 2 square. So here 5 over 2, this is equal to a 49 over 4. Then a is equal to 5 over 2 times 4 over 49. Simplify this. Then a is equal to 10 over 49. So the equations of in the vertex form will be fx equal to 10 over 49 bracket x minus 7 over 2 square plus 15 over 2. A2. Hence, if a bird is perched on the wire at point C, which is 100 cm horizontally from pole B, determine the height of the bird from the horizontal ground. So here the 100 centimeter, this is equal to 1 meter. So in the diagram, here will be the 1 meter. Then the horizontal distance of point C from A will be 6 meter. So now we already have the x coordinates of the point C. To find the height, which is the coordinate y, we just need to substitute the x coordinate, which is 6, into the equation that we found in A1. So here we can write this as f of 6, this is equal to 10 over 49. So the x here will be 6 minus 7 over 2 square plus 15 over 2. So the answer here will be 430 over 49, which is also equal to 8.776. Questions B. If the weather gets warmer, it is found that the electric wire becomes more sagging than the original positions and affects the change in the equations of the electric wire in vertex forms. In 4A1, what remains unchanged? As the electric wire becomes more sagging, as shown here, the shape of the parabolic here will become narrower. Then this is going to affect the A. And now, here will be the new minimum point. So here the x coordinates of the new minimum points will remain the same as 7 over 2. But the coordinates of the y will become smaller. Therefore, Q will also change. So in this case, what remains unchanged, that will be the P, which is the x coordinate. Questions 5a. Prove that 1 minus cos 2x minus sin 2x over sin x minus cos x, this is equal to 2 sin x. So here we need to refer to the double angle formula to prove this. So we're going to prove this from the left hand side. So for this part, cos 2x, so using the formula number 33 here, we can replace it with 1 minus 2 sine square x. And for the sin 2x, refer to the formula 32, so we can substitute it with 2 times sin x cos x. So here we're going to get 1 minus 1, so the 1 here will be cancelled, and the negative here will become positive. So here we're going to get 2 sine square x minus 2 sine x cos x. So for the numerator part, we have the 2 sine x as our common factor, so we can do the factorizations. So 2 sine x bracket sine x minus cos x. So now for the part sine x minus cos x here, we can cancel it. Therefore, what left will be 2 sine x, which is equal to the right hand side. Then it is proven. Questions B1. Sketch the graph of the equations y equal to modulus 1 minus cos 2x minus sin 2x over sin x minus cos x plus 1 for x is in between 0 to 2 pi. So for this part, this is the same as the one given in the questions A, which is equal to 2 sine x. Then we can replace this with 2 sine x. So now the equations will be y equal to modulus 2 sine x plus 1. So here is just sine x, therefore the number of cycle will be just 1. And the number 2 here will be the amplitude. So first, I'm just going to sketch the graph y equal to 2 sine x. And this will be the graph look like. As the 2 sine x have the modular signs, this means for this negative part, it will be reflected in the x-axis. Then this will be the graph y equal to modulus 2 sine x. As this is plus 1, which means the graph will be moving up 1 unit. Then this will be the graph y equal to modulus 2 sine x plus 1. Questions B2. By using the same axis, draw a suitable straight line to find the number of solutions to the equations modulus 6 pi sine x plus 3 pi equal to 3x for x in between 0 to 2 pi. So here we need to change these equations so that it will have modulus 2 sine x plus 1. Then we can replace this part with y. To do that, first we're going to move this 3 pi to the right hand side. This will equal to 3x minus 3 pi. Then I'm going to divide both sides with 3 pi. So here the pi can be cancelled, and this 3 and this 6 we can simplify this. Then we're going to have modulus 2 sine x. This is equal to 3x divided by 3 pi. This is equal to x over pi. Minus 3 pi divided by 3 pi, this is equal to 1. Next, I'm going to move this negative 1 to the left hand side. Then modulus 2 sine x plus 1 is equal to x over pi. So now for this part, we can substitute this with y. Therefore, the equation will be y equal to x over pi. So when we compare this to y equal to mx plus c, the c is equal to 0. So the first point that we can plot is at the origin. For the other points, I'm going to let x equal to pi. Then the equation will be y equal to pi divided by pi. Then the y is equal to 1. So here this will be the pi. So when x equal to pi, y is equal to 1. So we will have another point here. Then we can plot the straight lines. So here we have two intersection points. Therefore, the number of solutions will equal to 2. Question number 6. Given the sum of the second and third term of geometric progression is 30, while the second term is 9 less than the first term. All terms in this sequence are positive. A. Find the first term and the common ratio of the progressions. So for questions involving geometric progressions, you can always refer to the formula 11 to 13. So first, based on these informations, we can write that T2 plus T3, this is equal to 30. For T2, we can substitute it as AR 2 minus 1 and T3 as AR 3 minus 1, this is equal to 30. So AR plus AR square, this is equal to 30. So here we can factorize for these two terms. So I just going to take the A outside. So bracket R plus R square. So this is equal to 30. So based on the other informations here, so here we can write T2 is equal to T1 minus 9. Again, T2, we can substitute it as AR2 minus 1. T1 is the first term, so it's just going to be A. So move the A to the other side, so AR minus A, this is equal to negative 9. Again, we can factorize this, so A bracket R minus 1, this is equal to negative 9. So now we have two equations here. So let us label this as equation 1 and this as equation 2. So here we can eliminate the A by using equations 1 divided by equations 2. So here we can eliminate the A, and for the 30 over negative 9 we can simplify this. This will be 10 and this will be negative 3. So here we're going to do cross multiplications. So here we're going to get negative 3r minus 3r squared. This is equal to 10r minus 10. So this is a quadratic equation. So here I'm going to move everything to the left hand side so that I will have the A with the positive terms. So here 3r squared, 10r plus 3r, we're going to get 13r minus 10. This is equal to 0. Factorize this, so you're going to get 3r minus 2, and then the bracket will be r plus 5. This is equal to 0. So r is equal to 2 over 3, or r is equal to negative 5. So here is stated all terms in this sequence are positive. Therefore, the correct r will be r equal to positive 2 over 3. To find the A, we're going to substitute the r2 over 3 into equations number 2. So A bracket 2 over 3 minus 1, this is equal to negative 9. So A bracket negative 1 over 3 equal to negative 9. Then A will be negative 9 times negative 3, which is positive 27. Questions B. Determine whether 150 over 81 is a term in the progressions. Give your reasons. So here we're going to find this 150 over 81 is which term in these progressions. From there, we're going to determine whether this is a term in the progressions or not. So let's say this 150 over 81 is the nth term in these progressions. So Tn is equal to 150 over 81. So Tn, we can replace it with ARn minus 1. So A, we know that is 27. The R will be 2 over 3. Then the n minus 1. So this is equal to 150 over 81. So next we're going to move the 27 to the other side. It will be 150 over 81 divided by 27. So the answer here will be 50 over 729. To solve this, we're going to use the logarithms. So first, we're going to use log both tens on both sides. Using the power law, move the n minus 1 to the front. Then, move the log base tens of 2 over 3 to the other side. So here, n minus 1 is equal to 6.609. Then n is equal to 7.609. So here the n is referred to the number of terms. The n must be a positive integer. Therefore, 150 over 81 is not a term in the progressions. The reason will be the n is not an integer. Question 7. Diagram 4 shows parts of a curve y equal to square root x plus 4. A finds the area of the shaded region. To find the area of the shaded regions, we can use the area of the trapezium here minus the area under the curve here. So first we're going to find the area of the trapezium. To know what is the y-coordinate of the point S, we just need to substitute the x equal to 4 into the equations of the curve. So y is equal to square root of 4 plus 4, which is equal to 6. Then here will be 22 units and here will be 6 units. This will be the two parallel sides. And this number 4 here is going to be the height. So area of the trapezium will be 1 over 2 times 22 plus 6 times the height, which is equal to 56. To find the area under the curve, we need to integrate with the upper limit 4, lower limit 0 of this equation. So the x, square root x, we're going to write it as x to the power of 1 over 2 plus 4 in respect to x. So integrate this. So this will be x. 1 over 2, we need to plus 1, which is equal to 3 over 2. Then bring the power 3 over 2 down here. Plus integrate 4, we're going to get 4x. So next, we need to substitute the upper limit 4 into the parts that we integrate here. So 4 to the power of 2 over 3 over 3 over 2 plus 4 times 4. Then minus 0 to the power of 3 over 2 over 3 over 2 plus 4 times 0. So the answer here will equal to 64 over 3. So area of the shaded region will be 56 minus 64 over 3, which is equal to 104 over 3, or 34 and 2 over 3. Questions B. Calculate the volume of revolutions in terms of pi when the region bounded by the curve, the straight line y equal to 6, and the y-axis is rotated 360 degrees about the y-axis. So here will be the region bounded by the curve, y equal to 6, and the y-axis. So after the rotations, the volume will look like this. So based on the equations of the curve given, the y-intercept is going to be 4. It means this part here is equal to 4. So now we already have the upper limit and the lower limit, which is 6 and 4. As this region is rotated 360 degrees about the y-axis, then the volume we can find it by using, we're going to integrate BA pi x squared in respect to x. So first we're going to find the x squared. So based on the equations given here, square root of x, this is equal to y minus 4. So here when we square both sides, x is equal to bracket y minus 4 square. To get x squared, we're going to square both sides again. Then x squared is equal to bracket y minus 4 to the power of 4. So now the volume will be, so we're going to integrate from 6 to 4 pi, and the x squared will be the y minus 4 to the power of 4 in respect to y. So here you can bring the pi to the front. So this is equal to pi, so bracket here. So when you do the integrations for this part, so here the 4, the power of 4, we need to plus 1, which is equal to 5. We're going to bring down the power of 5 here and multiply with the differentiations of the y inside the bracket here, which is equal to 1. So next, we're going to substitute the upper limit and lower limits into the integrations. So first here, we're going to get 6 minus 4 to the power of 5 over 5 minus 4 minus 4 to the power of 5 over 5. So here we're going to get pi bracket 32 over 5 minus 0. Then the volume will be 32 over 5 pi. Questions number 8. Table 2 shows the value of two variables x and y obtained from an experiment. The variables x and y are related by the equations y equal to s over r root of x, where r and s are constants. So A plot log base 10 of y against log base 10 of x using a scale of 2 cm to 0.2 unit on the log base 10 of x axis and 2 cm to 0.1 unit on the log base 10 of y axis. Hence, draw the lines of best fit. So first, we're going to convert the data in the table x and y into log base 10 of y and log base 10 of x. So this will be the value of log base 10 of x and log base 10 of y. Remember, the data has to be written in two decimal places. So now we can plot the graph. So this will be the graph look like. Questions B. Using the graph in at A, finds the value of number 1 r and number 2 s. So first, we're going to need to reduce these equations. So here we're going to log base 10 on both sides. So on the right hand side, using the division law, we can split this as log base 10 of s minus log base 10 of, and here we can write this as r to the power x to the power of 1 over r. So for the power 1 over r, using the power law, we can bring this to the front. Minus 1 over r log base 10 of x. So based on the graph that we plot, the log base 10 of y is the capital Y, and the log base 10 of x here is the capital X. So if we rearrange these equations, then this is equal to negative 1 over r log base 10 of x plus log base 10 of s. And when we compare it with y equal to mx plus c, then the negative 1 over r is the gradient, and the log base 10 of x is the y-intercept. So to find the gradient, the 2 points that I'm going to use will be these points and the y-intercept. So here negative 1 over r, which is the gradient, is equal to 0.8 minus 0.04 over 1.2 minus 0. So negative 1 over r here is equal to 19 over 30. Then r will equal to negative 1 divided by 19 over 30, which is equal to negative 1.58. Number 2, so the log base 10 of s is the y-intercept, which is 0.04. Then s is equal to 10 to the power of 0.04. Then the answer will be 1.096. Questions number 9. Diagram 5 shows 3 points A, B, and C, which are the midpoints of the straight lines PQ, QR, and PR respectively, and forms a parallelogram PABC. A finds number 1 the equations of the straight lines PR. As PABC is a parallelogram, this means the gradient of PR is equal to the gradient of AB. So using the points A and B, then the gradient PR will be 3 minus negative 1 over negative 1 minus 3. So this will be 4 divided by negative 4, which is negative 1. So based on the diagram, the y-intercept of the straight line PR is negative 2. Then we already have the C of the PR. Then the equation of the straight line PR will be y equal to negative x minus 2. A2 finds the equations of the perpendicular bisector of the lines PQ. So here the point A is the midpoint of the straight line PQ. So this straight line here will be the perpendicular bisector of PQ. So here PQ is parallel to CB. Therefore, they are having the same gradient. So using the point B and C, then the gradient PQ will be -1 minus -2 over 3 minus 0. Then the gradient PQ will be 1 over 3. So for two straight lines that are perpendicular to each other, when we multiply its gradient, m1 times m2, the answer will be -1. So here let's say m2 is the gradient of the perpendicular bisector. So 1 over 3 times m2, this is equal to -1. Then m2 is equal to -3. So we already have the gradient of the perpendicular bisector PQ. Now the equation will be y equal to -3x plus c. So to find the c, we're going to substitute the coordinate a into the equations. So 3 equal to -3 times -1 plus c. So 3 equal to 3 plus c. So c equal to 3 minus 3, which is equal to 0. Then the equations of the perpendicular bisector of the lines PQ will be y equal to -3x. Questions B. The straight line PQ is extended to point S such that PQ to PS is equal to 2 to 3. Finds the coordinate of the points Q in terms of M and N. So based on the ratio given, here the ratio QS will be 3 minus 2, which is equal to 1. So as point A is the midpoint for the line segment PQ, then the ratio PA to AQ will be 1 as well. Then we can say that now the point Q is the midpoint for AS. Then the coordinate Q will be -1 plus m over 2, this is for the x coordinates, and 3 plus n over 2, then this will be the y coordinate. Question C. Finds the area of the triangle ABC and hence finds the area of the triangle PQR. As we know the coordinate of the points A, B, and C, then we can find the area using the shoelace formula. So here I'm going to arrange the coordinate anti-clockwise starting with the points A. So -1, 3, 0, -2, 3, -1, and end with the first coordinates. So here we're going to sum of all products in these directions. Then minus the sum of all products in these directions. So next, we're going to get 1 over 2. So for the first bracket, we're going to get the total of 11. Then minus, and the sum in the second bracket will be -5. So this is equal to 1 over 2 times. So here the total inside the modulus will be 16. Then the area will be 8. So next, we're going to find the area of the triangle PQR. So as point A, B, and C here are the midpoint, then the triangle PAC, ABC, ABQ, and BCR, they are identical. So to find the area of the triangle PQR, then we're going to use the area of the triangle ABC, which is 8. Then we're going to multiply it by 4. Then the area will be 32. Questions number 10. Diagram 6 shows a structure which consists of a semicircle, 2 quadrants, and a rectangle. Given the length and the width of the rectangle is 2y cm and x cm respectively, the perimeter of the building is 100 cm. A. Show that the area L of the structure is given by L equal to y, bracket 200 minus 3 pi y minus 12y. So for this semicircles, the diameter will be equal to 2y. Then the radius will be y. And these two will be the quadrant. So this part here is also the radius of the semicircle, which is the y. Then the radius of the quadrant will be y as well. Then this part here will be x, and this will be y. So for this rectangle, this part here will be 4y. Then the area of the rectangle will be 4y times x, which is 4xy. So if we combine these two quadrants together, then it will form a semicircle with the radius of y, which is equal to the semicircle here. And if we combine these two semicircles, then it's going to form a circle. So area of the circle is pi r squared. So here as the radius is y, then the area will be pi y squared. So if we compare the area that we found with the one given in the questions A, we need to substitute the x here with term in y so that we can get the equations here. So now using the informations, the perimeter of the building is 100 centimeter. So to find the perimeter, we're going to sum up first this part. So here we're going to get 6y plus 2x. As for this part, it is a circle. Then the circumference will be just 2 pi r. So here the r, we're going to substitute it with y. Then we're going to get 2 pi y. Then this is equal to 100. So here we're going to let the x to become the subject. So 2x is equal to 100 minus 6y minus 2 pi y. Next, we're going to move the number 2 to the other side. Then x is equal to 100 divided by 2 is 50 minus 6y divided by 2, 3y minus 2 pi y divided by 2, which is pi y. So next, we're going to substitute this into the equations L. So expand this, we're going to get 200y minus 12y squared minus 4 pi y squared. So for this part, we're going to get minus 3 pi y squared. Next, we're going to factorize this. So y bracket 200 minus 12y minus 3 pi y. Then the equations has been shown. Questions B. Finds the value of y when L is maximum. Hence, finds the maximum value of L. So first, we're going to differentiate L in respect to y, which is the dl dy, and let the dl dy equal to 0 to find the value of y when L is maximum. So from the equations given in 10a, first I'm going to expand it. So 200y minus 3 pi y squared minus 12y squared. So when we differentiate dl dy, we're going to get 200 minus 6 pi y minus 24y. Then we're going to let dl dy equal to 0. So first, this we can simplify this. So divide everything with number 2. So 100 minus 3 pi y minus 12y, this is equal to 0. So next, I'm going to move the term with y to the other side. So positive 3 pi y plus 12y, this one is equal to 100. So I want to find the value of y, so I'm going to factorize this. So y bracket 3 pi plus 12 equal to 100. Then y is equal to 100 divided by 3 pi plus 12, which is equal to 4.667. So to find the maximum value of y, we're going to substitute the value y, 4.667, into the equations L. So the y here, we're going to substitute it with the 4.667. Then the maximum value of L will equal to 466.72. Question C. Given that the radius of the semicircle increases at the rate of 0.7 cm per second when the structure is heated, find the rate of change of the area of the building when the radius of the semicircle is 12 cm. So this 0.7 is the dy dt, as the radius here will represent it using the letter y. The rate of change of the area of building, this will be the dl dt. So we're going to solve these questions using the chain rule. So based on the equations given in 10a, the chain rule will be dl dt, this is equal to dl dy times dy dt. So we already have the informations of dy dt. Next, we need to find the dl dy. In questions 10b, we already differentiate L in respect to y. So when the radius is equal to 12, which is the y, then dl dy will be 200 minus 6 pi times 12 minus 24 times 12, which is equal to negative 314.224. Then dl dt will equal to negative 314.224 times 0.7, which is equal to negative 219.96. Questions number 11. The mass of durians produced from a farm follows a normal distribution with a mean of 1.2 kg. It is given that the probability of a durian chosen at random from the farm has a mass less than 2 kg is 0.9452. A. If a worker chooses at random 5 durians, find the probability that all the 5 durians have the mass less than 2 kg. So this question A is about the binomial distributions. So here we want to refer to the formula number 23. So here the n is the 5 durian chosen. As we want to find the probability that all durians have the mass less than 2 kg, so here this 0.9452 will be its probability. And this will be the P, which is the success. And the failure will be Q equal to 1 minus 0.9452, which is 0.0548. So here 5 durian chosen at random and all of them have the mass of less than 2 kg. This will be P x equal to 5. This is equal to 5C5 bracket 0.9452 to the power of 5, then multiply 0.0548 to the power of 0. The answer will be 0.7544. Questions B. 4 workers are each tasked with choosing randomly 5 durians from the farm. Find the probability that more than 2 workers chose randomly all the 5 durians that have mass less than 2 kg. So for questions B, this is about the binomial distributions. So we're going to refer to this formula 23. So here is stated more than 2 workers out of 4 workers, which means either 3 workers or 4 workers. So here the probability that we want to find is for workers more than 2, which is Px greater than 2. This is equal to either 3 workers Px equal to 3 or 4 workers Px equal to 4. So the probability of all 5 durian has mass less than 2 kg is the same in the questions A. So the probability for the success one, which is the P, is equal to 0.7544. Then the Q will be 1 minus 0.7544, which is 0.2456. So next, we're going to substitute all the informations into the formula. So this is equal to 0.4218 plus 0.3239, which is equal to 0.7457. Question C. A durian is chosen at random from the farm. 1. Find the standard deviations of the durians that have mass less than 2 kg. So we're going to solve this using the normal distributions. So from the questions, we know that the probability of the durians that have mass less than 2 kg, the probability is 0.9452. This 2 kg is going to be the x. So here I can write probability P for x less than 2 kg. This is equal to 0.9452. Next, we'll convert this into standard normal distributions using the formula number 26. So here we know that the mean is equal to 1.2. Next, we can write this as probability. Now convert the x into z. This will be less than. So the x will be the 2 minus the mean, which is 1.2 over the standard deviations. This is equal to 0.9452. So next, I'm going to draw the standard normal distribution graph. So this probability is an area under the curve. As the z-score here is less than, then the area will be on the left-hand side. So if we shade from the left-hand side until the fz axis here, this is just equal to 0.5. So 0.9452 is more than that. So let's say until here, all of this shaded region here is representing the 0.9452. Then here will be our z-score, which is a positive one. Then for the part for the area greater than z, we're going to use 1 minus 0.9452, which is equal to 0.0548. So next, I can write this as, so the probability for z is greater than or equal to 0.8 over the standard deviations. This is equal to 0.0548. So here, based on the table, the probability of 0.0548, we have a z-score of 1.60. So here our z-score will be 0.8 over the standard deviations. So now I can write this as 0.8 over standard deviation is equal to 1.60. Then the standard deviation will be 0.8 divided by 1.60, which is equal to 0.5. Questions 2. Hence, finds the probability that the mass is more than 1.5 kg. So here this 1.5 kg is the x. So here we want to find probability P, x is greater than 1.5. Next, we're going to convert this into the standard score. So P is bracket Z greater than, so using the formula number 26, it will be 1.5 minus the mean, which is 1.2 over the standard deviations. So in question C1, we already find that the standard deviation is equal to 0.5. So this is equal to probability with the z-score greater than 0.6. So if you draw the graph of the standard normal distribution, it will look like this. So probably 0.6 is around here. As this is greater than, then the area will be on the right hand side. So from the table, when the z-score is 0.6, then the probability is 0.2743. Questions number 12. Table 3 show information related to 4 main ingredients and the quantity used by Mr. Rahim to make kueh bingka. A finds the value of x and of y. So X is the price index for the tapioca flour. To find X, it is equal to 6 ringgit divided by 4.8 times 100. The answer is 125. And Y is the price for the coconut milk in the year 2021. So when we take 3 ringgit, divide it by Y, and multiply it by 100, this will give us the price index, which is the 109. Solve this, Y is equal to RM 2.75. Questions B. The composite index for the cost of producing a box of kueh bingka in the year 2022 based on the year 2021 is 116. Finds the value of M. So to find the composite index of 116, we're going to use 125 multiplied with its weightage 150 plus 109 multiplied 150 plus 105 times 100 plus 120 times M over the total weightage, which is 150 plus 150 plus 100 plus M. This is equal to 116. So next we're going to get 45600 plus 120 M over 400 plus M. This is equal to 116. Next, move the 400 plus M to the other side. So we're going to get 116 times 400, which is 46400, plus 116 times M, which is 116 M. So 120 M minus 116 M, this is equal to 4M. And 46400 minus 45600, this is equal to 800. Then M is equal to 200. Question C. The increment in the cost of producing kueh bingka in 2023 from 2022 is the same as the increment in the cost of producing kueh bingka from 2021 to 2022. The cost price of kueh bingka in 2021 is 11 ringgit. Finds the selling price of kueh bingka if Mr. Rahim wants to obtain a profit of 25% in the year 2023. So in questions B, we already know that the composite index in the year 2022 based on 2021 is 116. As the increment in the year 2023 from the year 2022 is the same, then the composite index in the year 2023 based on 2022 will be 116 as well. So from here we can find the composite index in the year 2023 based on 2021 using the SMART formula. So here the 3 years involved will be 2021, 2022 and 2023. So here I'm going to label this as 116. And this part here will be the composite index in the year 2023 based on 2021. So using this method, this is A, this is B, and this will be the C. And here, A times B, this is equal to 100C. So here we're going to get 116 times 116. This is equal to 100 times the composite index 2023 based on 2021. Then the composite index will be 116 times 116 divided by 100, which is equal to 134.56. So here we know the cost price of the kueh bingka in 2021 is 11 ringgit. So now with this composite index, we can find the price in the year 2023. So here the price in the year, cost price in the year 2023 divided by 11 multiplied by 100. This is equal to 134.56. So the cost price in the year 2023, this is equal to RM 14 ringgit 80 cent. So to find the selling price to obtain a profit of 25%, So we're going to take the cost price, which is RM 14 ringgit 80 cent, and multiply it by 125 over 100, which is equal to RM 18 ringgit 50 cents. Questions number 13. Diagram 7 shows a quadrilateral PQRS on a horizontal plane. TSQP is a pyramid such that PQ equal to 10 cm, PS equal to 12 cm, and T is 5 cm vertically above P. Find A, the value of M. So here refer to the triangle QRS. This square root M is opposite the angle 64 degree. So using the cosine rule, we can find the value of M. So here, square root M square, this is equal to 21 square plus 19.5 square minus 2 times 21 times 19.5 cos 64 degree. So when we square the square root M, what left is just going to be M. Then the answer will be 462.22. Questions B finds the angle of the RSQ, which is located here. So this angle is opposite the 19.5, and we already know that what is the value of M, which is 462.22. Then we can find the angle here using the sine rule. So first, the value of the square root of 462.22, this is equal to 21.50. So using the sine rule, 19.5 over sine angle RSQ, this is equal to 21.50 divided by sine 64 degree. Solve this, the angle RSQ is equal to 54.61 degree. Question C. Finds the area in centimeter square of inclined plane STQ. So this will be the inclined plane STQ. As T is vertically above P, so the angle between TP and PQ here will be 90 degree. So the triangle TPQ is a right angle triangle. So using the Pythagoras theorem, we can find what is the length of TQ. So here TQ square, and this is equal to 5 square plus 10 square. So the length of TQ, this is equal to 11.18. And for the angle between TP and PS, the angle here will be 90 degree as well. So triangle TPS is also a right angle triangle. Again, using the Pythagoras theorem, we can find what is the length of TS. So TS square is equal to 12 square plus 5 square, which is equal to 13. So now we have the length of three sides of the inclined plane STQ. So first, you can find the area of the STQ using the Heron's formula. So first, we're going to find the semi-perimeter, which is the S. So semi-perimeter is equal to 11.18 plus 13 plus 21.50. Then we're going to divide it by 2, which is equal to 22.84. Then the area of the triangle STQ will be square root the semi-perimeter, which is the 22.84, times the semi-perimeter. We're going to minus it with one of the length. Let's say we start with the 11.18 times 22.84 minus the second length, which is 13, times 22.84 minus the third length, which is 21.50. Solve this, the area is equal to 59.26. Questions D. Finds the shortest length in centimeter from point T to the straight line SQ. Again, we're going to refer this to the inclined plane as TQ. So if I redraw the inclined plane as TQ, it will look like this. So the shortest distance between the point T to the length SQ will be a perpendicular straight line from the point T to SQ. So here will be 90 degrees. And this will be the shortest length. So here, the shortest length is also the height for the triangle STQ. So here, let's say I label this shortest length as H. In question C, we find that the area of the triangle STQ is equal to 59.26. So if we use another formula, let's say 1 over 2 times base times height, the area that we find for the STQ will also be equal to 59.26. So here the base will be the 21.50. Multiply the height, which is the shortest length. This is equal to 59.26. So solve this, the H is equal to 5.513. Questions number 14. Ross Workshop produced two types of chair, P and Q. The production of each type of chair involves two processes, making and painting. Table 4 shows the time taken to make and paint a unit of chair of type P and a unit of chair of type Q. The maximum total time for making both chair is 5.5 hours and the time for painting both chair is at least 5 hours and 50 minutes. The ratio of the number of chair P to the number of chair Q is not more than 4 to 5. Ross Workshop produced X unit of chair P and Y unit of chair Q per day. A. Write three inequalities which satisfies all the above constraints. So the first inequalities is based on these informations. As the time taken in making and painting are in minutes, then we're going to convert this 5.5 hours into minutes, which is 5.5 times 60 equal to 330. And the keyword here will be maximum, which is less than or equal to. So now refer to the time of making. The first inequalities will be 45x plus 30y less than or equal to 330. Based on this information, we're going to get the second inequalities. Again, we're going to change this 5 hours and 50 minutes into minutes, which is 350 minutes. Here, the keyword will be at least, which is greater than or equal to. So now refer to the time of painting. The second inequalities will be 50x plus 70y greater than or equal to 350. The third inequalities is based on the ratio here. The keyword here will be not more than, which is less than or equal to. So here, x to y is less than or equal to 4 to 5. Next, I can write this ratio in the form of fraction, which is going to be x over y less than or equal to 4 over 5. So here I'm going to write the third inequalities with y as the subject. So I'm going to move the y to the other side. So x is less than or equal to 4 over 5y. So this is the same meaning as 4 over 5y is greater than or equal to x. Then y is greater than or equal to 5 over 4x. Questions B. Using a scale of 2 cm to a unit of chair on both axes, construct and shade the region R which satisfies all the above constraints. So here for the first inequalities, the equation will be 45x plus 30y is equal to 330. So here I can simplify this by dividing every term with 15. Then we're going to get 3x plus 2y is equal to 22. To find the y-intercepts, I'm going to substitute the x here with 0. Then we're going to get 2y equal to 22. then y is equal to 11. To find the x-intercept, I'm going to substitute the y here with 0. Then 3x is equal to 22. Then x is equal to 22 over 3, which is equal to 7.33. So this will be the 2 points that we're going to plot for this straight lines. For the second inequalities, the equation will be 50x plus 70y equal to 350. We can simplify this dividing every terms with 10. Then 5x plus 7y is equal to 35. To find the y-intercept, we're going to substitute the x here with 0. Then 7y is equal to 35. Then y is equal to 5. To find the x-intercept, we're going to substitute the y here with 0. Then 5x is equal to 35. Then x is equal to 7. Then we already have 2 points to plot on the graph. For the third inequalities, the equation will be y equal to 5 over 4x. So based on these equations, the c is equal to 0. Then the y-intercept is 0. For the other points, I'm going to substitute the x here with number 4. Then y is equal to 5 over 4 times 4, which is equal to 5. So for the first equations with these points, it will be look like this. Now for the second equations with these points, it will look like this. And for the third equation with the y-intercept equal to 0 and this point, it will be look like this. So now to shape the region R, so based on the first inequalities, this is less than or equal to, which will be on this side. And for the second inequalities, the sign is greater than or equal to. Then it will be above this side. And for the third inequalities, it is greater than or equal to. Then it will be above this side. So the region which satisfies all the above constraints will be here. Question C. Use the graph constructed in 14b to answer the following questions. 1. The range of JQ if 3 units of JP are produced per day. So here, the JP is represented by the x-axis. So 3 units of JP is mean x equal to 3. So this will be the straight lines x equal to 3. So the range of JQ must be within the region R. So based on the graph here, it is in between 3.7 to 6.5. But the number of J must be a whole number. So the range of JQ will be in between 4 to 6. As JQ is represented by the letter Y, so Y is greater than or equal to 4 but less than or equal to 6. Questions number 2. The maximum profit per day if the profit obtained from a unit of JP and a unit of JQ are 16 ringgit and 10 ringgit respectively. So here the formula to find the maximum profit will be the number of JP, which is x multiplied with 16 ringgit. So 16x plus number of JQ, y multiplied with 10, which is 10y. To find the maximum profit, you can just substitute the coordinates xy of each of the vertex within the region R here into the formula 16x plus 10y. Which coordinate given you the highest value, that will be the maximum profit. So after trying 4 of the coordinate of the vertex, the one with the coordinate 4, 5 will give you the maximum profit. Maximum profit will be 16 times 4 plus 10 times 5, which is equal to RM 114. Questions number 15. A particle moves along a straight line from a fixed point O. Its velocity v, t second after point O is given by v equal to t squared minus pt plus 15, where p is a constant. Given that the acceleration of the particle is 4 when t is equal to 6, the particle stops at point A and B along the straight lines. Find A1, the value of p. So here we can find the value of p using these informations. Acceleration is equal to dv dt. So here we're going to get 2t minus p. So when t is 6, a is equal to 4. So now for the a, we can replace it with 2t minus p. So for the t, we're going to substitute it with 6. So 12 minus p is equal to 4. Then p is equal to 12 minus 4. Then p is equal to 8. Questions number 2. Finds the times in second when the particle is at A and B. So based on the informations, the particles stop at point A and B, which means the velocity of particles at point A and B is equal to 0. So in questions A1, we already found that the P is equal to 8. Therefore, the equations of the velocity will be t squared minus 8t plus 15 is equal to 0. So this is a quadratic equations using factorizations. Bracket t minus 3. Another bracket will be t minus 5 equal to 0. So t is equal to 3 or t is equal to 5. So that will be the times when the particles is at A and B. Questions B. Sketch the velocity time graph of the particles for x in between 0 to 5. Hence, find the total distance in meter traveled by the particles in the first 5 seconds. So based on the equations of the velocity, this is a quadratic graph. So based on the equation here, the A is equal to 1, which is greater than 0. Then the shape of the quadratic graph will be a small one. And here, the C, which is the y-intercept, is equal to 15. And in questions A2, when we let the v equal to 0, we find that the t is equal to 3 and t is equal to 5, which is the root. Then this will be the velocity time graph. So next, we're going to find the total distance traveled in the first 5 seconds. So from the velocity time graph, the distance traveled will be area under the curve. So to find the area under the curve, we're going to use integration. So one part of the area is above the t-axis, another part is below the t-axis. So we're going to integrate this separately. So let's say for the part which is above the t-axis, we label this as part A. Then A will be integrate from 3 to 0, t squared minus t plus 15 in respect to t. So next, we're going to get t cubed over 3 minus 8t squared over 2 plus 15t. So for the 2 and 8 here, we can simplify this. So next, we're going to substitute the upper limit and lower limit into the equation. So here, 3 cubed over 3 minus 4 times 3 squared plus 15 times 3 minus 0 cubed over 3 minus 4 times 0 squared plus 15 times 0. So the answer here will be 18 minus 0, which is equal to 18. So from 0 to 3, the particles travel 18 meters. Next, for the parts 3 to 5 seconds, we're going to label this as part B. Then B is equal to, we're going to integrate from 5 to 3, the same equations. So here we're going to get 5 cubed over 3 minus 4 times 5 squared plus 15 times 5. Then minus with 3 cubed over 3 minus 4 times 3 squared plus 15 times 3. So here the answer will be 50 over 3 minus 18, which is negative 4 over 3. The area B is negative because it is below the t-axis. But area is always positive. So therefore, the part B, we can put a modulus to our answer. So the B is positive 4 over 3. So the distance traveled by the particles from 3 to 5 seconds will be 4 over 3 meter. So now the total distance will be 18 plus 4 over 3, which is equal to 58 over 3 meter.